Hey, hello everyone. Hope everyone are doing fine and you all are accommodating to these new norms of working from home and attending the conferences virtually. This is my second virtual conference this year, and I hope you all are catching up with it. And thanks for taking some time to go through this session of enriching the data versus filtering the data in Apache Spark. I hope this presentation provides a context of uh, two different patterns which you can use in your Spark based application. Let's get started. Before we dive into the technical topic, I thought I will give a brief introduction about myself. Uh, so I'm a master software engineer working in Capital, and if you own any of our credit card, basically you go and swipe the card in Starbucks, buy a coffee. How much you are supposed to earn as a rewards is computed by my application, and I have been developing Spark based application from its initial days. I just called out 1.2 and with Java 2. And I have been following big data technology very closely, and I have been working with big data technologies for quite a while. And I have been contributing to Capital on Medium tech blogs regularly, and I have written multiple blogs in our Medium site. And you can hit me in Twitter and LinkedIn. I have provided my handles. Okay, so here is the agenda for today's discussion. So first we will hit upon the reward space use case, what we have gone through in Capital One, and that will set us up for the discussion on what kind of patterns we have used and which one provide us more leverage. So that those are all the things we'll get to know more on the use case context. And first, we will touch upon filtering approach and how we have used filtering approach in our use case, and what kind of problem it had with that particular approach, and how we overcome that particular approach with another approach called enriching the data approach. And finally, we will conclude and leave some room for question Q&A. So before we dive into the use case, uh, so by now we may know like Capital One is pretty much into the tech space, and we are probably pioneer in banking sector when it comes to the technology, and we develop most of our softwares with open source first, and pretty soon we are going to be operating fully on cloud, and we will be exiting our data center very soon. And we use Apache Spark extensively for a variety of our use cases, be the batch, streaming, and machine learning workloads. It's used extensively across the enterprise. Okay, so we will get into the use case in detail. So this particular use case comes from rewards part of Capital, and for easy understanding and the brevity, I have abstracted the application to a simpler context. So we apply specific account-based rules and some specific transaction-based rules, and we compute the earn and we persist them in the database, right? So you are swiping the credit card in a Starbucks and buying coffee, and you are supposed to get a particular earn, right? So that is what this whole application does. So it gets that swipe and provides you the rewards, and it's completely done in Apache Spark, and that's the use case we are going to discuss using two different approaches. One, we'll start off with the filtering based approach, and we will get into another approach and why we chose. Right, first we will get into the filtering based approach. So the filtering based approach uses Spark's inner join, right? So joins are like pretty much standard, and we use for most of this dataset computations, right? So in this particular filtering based approach, what we are doing is we are bringing in two different data sets, and we are doing inner join on particular join criteria, and that's what I mean by a stage and how the computation happens. And for just to get started, I have provided a filtering based approach diagram. We will get into a database example later. So what filtering based approach with our credit card use case, whatever I was mentioning, how it flows through, right? So we are bringing in 10 transactions, and we are applying probably a account based filter, and that filters out 5 transactions, which is done in memory using our Spark inner join. So which filters out 5 transaction, I mean. And then we are applying transaction based business rules. For example, transaction based business rule is just consider only the purchase, don't consider the payments. Similar to that, for account based, it's something like uh, whether the account is in good standing. This is in a not a defaulted account, or those kind of the simple cases is what I'm defining by uh, account or business based rules, right? So then that transaction based rules filters out another 3, finally yields us 2 transaction, which is what we are using to compute earn, right? So this is what I mean by a filtering approach. We are starting off with 10 transactions, we are ending up with 2 transactions, which is a valid result. But on the whole process, we have filtered out, in this simple example, we have filtered out 8 transactions which happened in memory, right? So let's get into database, I mean the data-based example for the same use case, right? So okay, so the same example, I'm just getting 3 transactions, and we are trying to apply account-based rules for on those transactions. So in this example, transaction dataset is left-hand dataset, and account-based dataset is right-hand dataset, and we are reading good standing accounts from account-based dataset, and when we are trying to join that using the inner join in memory, that yields us a result, right? So which probably you by you know that what could be the result. So it removes a defaulted transaction and yields us 2, which is good standing accounts transactions. The same way, when we apply transaction based inner join, where we are trying to read purchase category, and we are applying inner join on the same transaction dataset, yields us 1 transaction. This is the valid transaction where account is in a good standing condition, and which is a purchase transaction, and it is supposed to earn rewards, right? So this is what I mean by a filtering approach, where we are starting off with 3 transactions. In this simple example, we are ending up with 1 transaction, which is a valid transaction. But this kind of approach has its own problems, right? We will get into that kind of thing now. So what are the issues filtering approach has? So it's pretty simple to deal with that kind of small data set, but that's not how typical real-time use cases are, right? With big data processing, and what happens is, when you deploy this kind of filtering approach on a large data set, it becomes very hard to debug the application post deployment. And once the application is deployed, because with the sheer volume of processing, it becomes hard for us to see why this particular transmission is not making into the computation of earn, right? So if we are dealing with say 20 million transactions, 40 million transactions on a given day, right? How to identify on a granular level what happened to the transactions, right? That's what I mean by back tracing of data is hard when the computation happens in memory, right? In the same example, we are starting off with 3 and we are ending up with 1 transaction. We know 2 non-processing transactions is what got filtered out, but how to ensure that that is what always happens, right? That's what back tracing and be from uh, a regulated industry, we need to have this kind of capability to backtrace why a particular transaction is not making through, right? With this volume of processing, what matters is not what we computed. We need to ensure what we computed and why we are not computing for other transactions as well, right? We can argue that counts is a operation which everyone uses when they're rapidly prototyping the Spark-based application, right? But counts is not a efficient way of doing things when you're dealing with a huge data set, right? We can argue that we can do counts at each stage in the same example and try to get the number of records and we can reconcile. But the issue is counts always provides us the information on how many transactions made it, but what we need in this case is why it did not make it through. So the contextual information at each stage counts cannot provide. Counts can provide only how many got processed. And everyone in Spark world knows that counts is a costly operation. And it puts a pressure on the driver side, and typically we tend to avoid counts, but this can be mitigated if we still sticking to the filtering approach, right? But how did we overcome this filtering based approach issue without having the counts? That's when we adopted enriching the data approach. So enriching the data approach, the same example we will go through in the lens of enriching the data approach, right? Before we start, the key thing in enriching the data approach is here we don't use the Spark inner join. Instead, we use left outer join. Instead of filtering the data, what we do is we keep on enriching the information from, excuse me, from left hand side, sorry, the right hand side into the left hand side data set. So which means in the same example, right, we are bringing in 10 transactions and we are trying to do left outer join on account based same 5 transactions, right? Instead of filtering out 5 transactions which happened in the previous pattern, what we are doing in this is we are bringing in only the information what we need from right hand dataset into the left hand dataset, but we are not filtering out. Instead, we are just enriching the data. So to the same use case, we are adding what we need from accounts, and then same 10 transaction goes through the next stage where we are adding transaction based information into the same data set. So it keeps the number of transaction intact, and with that you apply a business logic which will yield us the same 2 transactions which we are supposed to earn, which is the desired result what we need, and how we are arriving at the same conclusion or the same result is what's slightly different when we are adopting the enriching the data approach. We will go through the similar data-based example for enriching as well, similar to what we did with the filtering approach. So we will take the same example where we have same 3 transactions and we are bringing the same accounts, the same example what we used in the filtering the data approach. So when we try to do a left outer join on this same data sets, what happens in this case is the number of transactions remains intact, but we are bringing in what we need from the accounts dataset into the transaction dataset. So which yields us the result set like this. So if you see here, we need the status of the account at that point of processing, mostly the stateful information at the point of the computation, right? So if you see here the result set, the same three transactions which is enhanced with the account status into the data set. And while we do the same for transaction based, where we are bringing in the categories, and when we do the left outer join and enhance the transaction data set with the category, it yields us this, right? So here we are bringing in the category, which is probably a purchase, payment, this simple example. And using this same example, what we can do is now we have the data set. Now we can apply the business rules, whatever we want to capture on top of this. And that we can use a particular flags. This is the pattern we have adapted. So while we apply the business logic, it can be multiple flags. You can maintain which means that how much granular information you want to uh, keep on holding to this, right? In this, I have just shown only a simple flag which says is eligible for next stage, which is computed based on the data set where the status is good and the category is purchase. So then only for that it sets it true, the rest of things it's false. We can go one more granular level and capture the information by going to the each and every column and capture that as a stateful flag, and then act on those flags and have one final flag which you can use for your next stage of competition. So in this example, so the eligible for next stage flag is set based on status of good and the purchase category. So which yields us one transaction, which is the same result what we have achieved with the filtering approach as well. But with enhanced enriching approach, right? What we are doing is we are capturing additional information at each stage of the computation. This is what makes it easy for us to backtrace or go back and see why this particular transaction is not making through. That kind of granular information helps us post deployment. Now let's see what are the advantages of enriching or filtering approach. So data from each stage is enhanced or enriched into the original data set. So in this example, what we have seen, we are bringing in account information, what we need to act on that particular data set. We are enriching that to our original data set. So it captures the state information at that point of the computation, which makes it easier to debug or even analyze the data set later. So we can go back and see why this particular transaction is not making it through. And with the flags approach, you will be able to see, oh, this particular flag is set to false. So which means because of that particular stage is what your transaction is not making it for computing the earn. So and also we are capturing the data columns or flags at each stage, which gives us more granular details for backtracing the transactions, right? So the example of transaction-based business rules or account-based business rules, here we are trying to see its good standing accounts or purchase transactions. So we know the transaction which did not make it through falls into any one of this case. So for a huge volume of processing, we know we are arriving at the desired result, but how we are going back and reconciling the data which is not making it through, that is very much essential for this kind of regulated industry, where we need to go back and see each transaction at that granular level, right? So enriching the data approach provides us that kind of flexibility and granular details. And you don't need to do costly counts operation at each stage of the computation. So instead, you have the details, whatever we are capturing as flags or the additional columns which got enriched at the time of the processing. That's what we can use for analyzing or debugging at the later stage. So there is no need of uh, counts at any stage. This is a huge win compared to the filtering. Even though if we use counts, which may not be providing all the details what we need, it's a costly operation which may clearly avoid if you're doing enriching approach on a huge data set. So we had the filtering based version 1 in production for a few months, and uh, after deployment we found out that it was becoming cumbersome for us to backtrace the transactions and also to get into the details of the transaction which is not making it through because of mainly all the computation whatever we have been doing, the bunch of business rules we have been applying was yielding us the result. But how to go back and see the transactions which got filtered out in memory and why it got filtered out. So that kind of problem we had post deployment, and after deploying itself, we immediately in a few months we started iterating on our version 2 using the filtering approach, and we have deployed the the enriching the data approach based version 2. It was in development for a few months, and we deployed that to production as our version 2. Yeah, so then we made the switch to the enriching based version 2 in production, and that particular pattern based Spark application is what currently is successfully running in our environment production for a few years now. And this is the approach we are using to provide millions of miles cash and points as rewards to our capital loan customer. So if you are using our credit card and making a swipe, as I mentioned earlier in my uh, initial discussion, that our application is pretty much what computes the earn, what you are supposed to earn for your credit card swipes. And if you have used our credit card in any of the merchants, and this is how your transaction flows through in production using the enriching the data approach. Thank you everyone for the opportunity. What's in your wallet?